In our last video, we were able to set this problem up. We were able to find our objective function in terms of one variable. So we've got r equals 10x minus 0.001x squared, and we said we were trying to maximize this function. We also found the domain of this function. It's a closed interval this time, but between 0 and 10,000. Regardless of whether we have an open interval or a closed interval, the first thing that we need to do is find the critical points of this function. So first we need to take the derivative. I'm going to find r prime. And in this case, we're going to have 10 minus 0.002x. I've got my derivative. I want to find places where r prime is equal to 0 and places where r prime does not exist. If r prime is equal to 0, we'll have 10 minus 0.002x equals 0. And if we solve this for x really quickly, we'll have, let's see, 10 is equal to 0.002x. So that means that x is equal to 5,000 here. And I want to, again, make sure that that critical number that I found is that included in my domain. In this problem, yes it is. X equals 5,000 does live between 0 and 10,000. So that's good. The other case I need to consider is places where r prime does not exist. If I look at the equation for r prime, though, it's a polynomial. So in this case, r prime is a polynomial. So that means we're not going to have to worry about any other additional critical numbers. We only have the one x equals 5,000. So we have our critical numbers, and we know, we said last time that our domain was 0 to 10,000, and we said we were working on a closed interval this time. So what I'd like to do then is make sure that we find the absolute maximum of our interval, of our function on this interval. Now, because we're working with a closed interval, I know that the absolute maximum can occur in one of two places. It can occur either at this critical number that I found, or it can occur at the endpoints of my function, so either 0 or 10,000. And if we think back to in the last section, in section 4.5, when we were finding absolute extrema on a closed interval, once we have our critical numbers in the interval and the endpoints of the interval, we're going to take all three of those in this case and plug those back into our objective function. And we're simply going to take the maximum of those, the greatest y value here. So I'm going to take those 3 points that I found and plug those into my objective function. So I'm going to plug them into r of x. Keep in mind that's r of x, not r prime of x, but I want to plug those into r of x. So we'll start with the critical number first here. We're going to say r of 5,000. Here in this problem, I'll have 10 times 5,000 minus 0.001 times 5,000 squared. And let's see, if I plug 5,000 into my function, I ended up with a revenue of $25,000. So that seems pretty good, but remember, I need to check the endpoints of my interval as well. I need to check 0 and 10,000. And the way that I'm going to check those is I'm going to plug those into my revenue function as well here. So if I take r of 0, that's going to be 10 times 0 minus 0.001 times 0 squared. In this case, we'll have a revenue of $0, which doesn't really sound all that exciting here for us. So that means it's less than 25,000. That's not going to be our absolute maximum. And then I'll do the same thing with our right endpoint here with 10,000. So r of 10,000 is equal to 10 times 10,000 minus 0.001 times 10,000 squared. And if we crunch some numbers here, we're actually going to end up with $0 once again. So I have three Y values to consider right now. I have $25,000, I have $0, and then I have $0 again. Keeping in mind that we want to maximize this function, I want to pick the greatest Y value. So that means that I want 25,000. This is my absolute maximum. So this is excellent news. We've kind of done most of the heavy lifting of this problem. We've found our absolute maximum. We know it occurs at x equals 5,000. Now the last thing I want to do here is make sure that I'm actually answering the question that's being asked. So if I go back up and look at this problem, let's see. Let's erase some of this highlighting so that we can focus on the important questions. If I skip to the second part of this, it says, what price should the company charge for the buttons in order to maximize revenue? And what is the maximum revenue? Well, the maximum revenue, the second question, we actually already have that answer. We found the maximum revenue. We plugged 5,000 into our revenue function, and this is $25,000. So we can actually say it's not even just an absolute maximum, it's an absolute maximum revenue. So that's awesome. We've got our part of our answer right there. We are still missing one other piece of it, though. The question also asked, what price should the company charge in order to maximize the revenue? And for that, I'm going to look for, where are we using the price variable p? Well, we said right here, p equals 10 minus 0.001x. So I'm going to take the x value that gave us our maximum revenue, and our x value was x equals 5,000. That was the number that we plugged into our revenue function. And I'm just going to plug that into our price demand equation. So we said P is equal to 10 minus 0.001x, but instead of x, I'm going to go ahead and plug in the x value that gave us our maximum, which was 5,000. So we'll have 10 minus 0.001 times 5,000, and in this case we'll end up with a price of $5. This is the price that we should charge for each button if we want to achieve our maximum revenue. Based on the information that's been given to us, if we charge anything other than $5, we're not going to get as much money in revenue.